Alright, let's take a look at the review sheet for this test this upcoming Friday. First part, which relationship describes a negative correlation? Now, if we're following our highlighting techniques, we're going to first stop, and I'm going to highlight negative and correlation. Okay? I'm going to stop and dump everything I know about a negative correlation. That means one's increasing, one's decreasing. It's a relationship. It'd be slanted down. So those are some of the things that I know about negative correlation. So let's look at our answer choices. Child's age and his height. So generally speaking, as a child ages, or his age increases, what happens to his height? It's also increasing. If they're both increasing, that is a positive correlation and is therefore not negative. The height of a candle and the amount of time it's been burning. So the longer a candle burns, what happens to its height? It's going to decrease. They're doing opposite things, so this is a negative correlation. Let's make sure we don't have a better answer choice. The number of hamburgers ordered and the total cost. The more hamburgers you order, the more it's going to cost. Both going up, it's positive. The number of shoppers at a mall, so the more shoppers you have, generally speaking, the more cars you're going to have. They're both increasing, so again, it's positive. Remember, positive doesn't just mean they're both increasing. It also means that they're both decreasing. Negative and a negative gives you a positive. Okay? So it's not D, it's not C. The answer is B. Now the second part to that question says, which of the above answer choices are causations? So we're talking about causations. One thing causes the other. So looking at A, does the child's age cause his height to increase? Now this one's kind of iffy and could be argued both ways. But if you're talking about a distinct period of time, so for example, maybe from birth until after puberty, then yes, his age is going to increase his height. So I would say that A is a causation. Looking at B, the height of a candle and the amount of time it's been burning. Does burning a candle for a long time cause it to decrease in height? Yes, it does. That would be a causation. The number of hamburgers ordered and the total cost. Does ordering more hamburgers cause the cost to increase? Yes, it does. The number of shoppers at a mall and the number of cars in the parking lot. Do the numbers of shoppers at the mall cause the number of cars in the parking lot to increase? Not necessarily. Those people could have carpooled, they could have walked there, they could have ridden the bus. So there's several other different variables that you have to include. So D would not be considered a causation. Let's take a look at number 2. Lakeisha input the data into lists on her graphing calculator shown below. Okay, you will get the cheat sheet for calculators to use on your test. So use that, since this one's asking specifically about the calculator. When she looks at the calculator graph, she sees only 5 of the 7 points. What does Lakeisha need to do so that you can see all of the points? A, she needs to turn the stat plot on. Well, if it wasn't on, you wouldn't be able to see points at all. So it's not A. She needs to enter a function into y equals. When you enter a function, it's going to draw a line through it. Does this one have a line drawn through it? No, but that wouldn't show us more points. That would show us the line. She needs to change the type of marker used in plot 1. So here it's an open circle. Maybe the plot would be a little star. Maybe it'd be a closed circle. All that does is change what it looks like. She needs to change her window settings. Looking over here, X-min and X-max. So L1 are the X values, L2 are the Y values. So X values go from -3 to +3. That would be included in this -10 to +10. Let's look at the Y's. That's from 19 to 1. So y min and y max, the y min is negative 10, so it goes way lower than it needs to. The y max is 10. We need to go all the way up to 19. So this should actually be approximately 20. So she does. She needs to change her window settings. 3. Use the scatter plot at the right to answer the following questions. Input the data into your graphing calculator. As the x values increase, the y values... Okay, so first let's input them in our calculator. Again, you're going to have your calculator cheat sheet. To input our points, we click Stat, Enter. So I'm going to go on my calculator. I'm going to click Stat, Enter. I'm going to type in my points. So I have negative 2, negative 1.2, 1, 4.5, 6, 7.3, 9. And my y values, I have 13, 10.5, 4.2, negative 5, negative 12, negative 14, negative 19.2. Okay, so generally speaking, these are increasing, and these over here are decreasing. As the x values increase, the y values decrease. So what type of correlation exists? If one's going up and the other's going down, this is a negative correlation. So explain why each line would or would not be a good trend line for the data. Okay, so I'm going to find my trend line first because you are going to be asked to do that on your test. So what you need to do now that we have it entered into our stat is we need to make sure that our R values are on, since that will also play an important part on the next one. So to make sure your R values are on, you click second 0, second 0, and I'm going to scroll down till I see diagnostics on. And I click enter, enter. Once they're on, now I can find my actual equation. To find the equation, you do stat, right, 4, enter. So going to my calculator, stat, right, click the 4, and I click enter, all the way down to calculate. So my equation would be y equals negative 2.9 x plus 7.1. The a value is your slope, the b value is the y-intercept. So let's compare these. Explain why each line would or would not be a good trend line for the data. So 6x minus 2, comparing that to this. No. This shows a positive slope. This has a negative y-intercept. And it's way too steep. We're going from a 3 to a 6. All right, what about this one? Negative 2x plus 9. That's pretty close. I would say yes. I'd say it's a little too flat. Since it's smaller than a 3, since that's almost a 3. And the y-intercept is a little too high. But generally speaking, it's a good trend line. Negative 3x plus 7. Okay, we're almost right on point here. If you were to round these to whole numbers, then it's exactly what we need. This last one, 2.8x plus 6. The y-intercept's not too far off, so the y-intercept is a little low. But instead of a positive slope, it needs a negative slope. So that's how we would change the lines. Take what we want and look at how it varies. So this is not a good trend line. Alright, D. Using the best trend line from part C above, predict the y value when. So we're going to use this trend line. This was exactly what we wanted right here. So we're going to go plug that in y equals. So negative 3x plus 7. And we're going to predict the y value when x is 2. So when x is 2, y is 1. When x is negative 3, and scroll up to negative 3, y is 16. When x is 0, y is 7. Simple as that. If you don't have a calculator, this gets much more difficult. You would have to plug in these x values into your equation, which we could do. We could take y equals negative 3. Instead of x, we put 0 plus 7. Negative 3 times 0 is 0, so it would just be y equals 7. You could do the same for each one. Y equals negative 3 times 2 plus 7, so y equals negative 6 plus 7, so y equals 1. And I'll leave that last one for you to do. Flipping over to the back, we have another set of data. So we need to find the approximate window. X-min. This left column is your x, and this is your y. So what's the smallest x value that we have? 1. So we want it just a little bit lower than 1. So I'm going to say negative 2. For the x max, the largest x value we have is 10. So we want it just a little bit higher. So I'm going to say 12. Now let's move on to the y values. The smallest y value we have is 215. So a little bit lower, I'm going to say 210. Largest y value is 2250. So I'm going to say 2255. So we want it just a little bit higher. So now they want the equation. So I'm going to go back to my stat, enter, and I'm going to retype my points. So I scroll up to the title and click clear and go down, and it'll clear all my data. Clear and go down. I don't want to reset my calculator because then I'll have to do the diagnostics on again. So I'm going to input my new points. 1, 2, 3, 5, 7, 10. 215, 445, 635, 1100, 1525, 2250. Now, once I have them entered in, I click Stat, Write, 4, and there's my equation. So my equation is y equals 224.9x minus 20.99. The correlation coefficient is this R value, which is 0.999. The correlation, looking at that coefficient, is positive. closer the number is to 1, the stronger it is. 0.99 is pretty stinking close to 1. So this is a great fit. What do you have to turn on in order to see the correlation coefficient R? So going back to the last set of steps, you have to turn on your diagnostics to be able to get that R value. Look at each function notation below. Circle the correct movement of the original function f of x based on the transformation indicated in the notation. So number 5, this plus 3, it's on the outside, so it's going to be going up 3. Six has f of 1/3 x. It is inside, and anytime it's inside, it's horizontal. So this is going to be a horizontal stretch. We didn't talk about horizontal changes, so don't worry too much about that. 7, 3 times f of x. It's on the outside, so you're going to be dealing with vertical. And it's going to be a vertical stretch. It's on the inside, so we know it's left to right. So we can eliminate down 3 units. And anytime it's in the parentheses, it's opposite of what you think. So minus actually means right 3. F of 3x, again, it's inside, so it's horizontal. And it's the opposite of what you think. So 3 would normally stretch it. So for horizontal, it's going to be a compression. F of negative x. It's inside, so we're dealing with horizontal, and the negative flips it. Here, 11, it's outside the parentheses, so we know we're going up or down. So you can eliminate left and right, and it must be down 3 units. 12, the negative is on the outside of the parentheses, so we're dealing with a vertical flip. 13, the 1/3 is outside of the parentheses, so it's vertical. And it's a compression because the number's less than 1. Here, it's inside parentheses, so you know it's left or right, so eliminate that middle one. And it's opposite, so instead of positive, it's going to make us go left. So you need to ask yourself 2 questions. 1, is it inside parentheses, because that makes it horizontal, and opposite, or is it outside parentheses? Because that makes it vertical, and exactly what you think. And I actually grouped together the 2 different changes, so there's only one question you need to ask yourself. Is it inside the parentheses or outside of the parentheses? The graph below represents f of x. So we're talking some more about transformations. Still, we're asking ourselves, is it in the parentheses or out of the parentheses? So here for number 15, it's in the parentheses, so it's horizontal. And it's opposite of what we think, so it's right 3. So we're going to take each of these points and go right 3. 1, 2, 3. So I'm at negative 1, 4. Right 3. 1, 2, 3. So I'm at 1, 0. 1, 2, 3. I'm at 3, 3. 1, 2, 3. I'm at 5, 0. 1, 2, 3. I'm at 7, 4. I took each dot and I counted over, right 3. For this next one, number 16, it's on the outside, so it's vertical. So I'm going down 3. So I'm going to take each original dot and I'm going to count down 3. 1, 2, 3. So I'm at 4, 1. 1, 2, 3. I'm at 2, negative 3. 1, 2, 3. I'm at 0, 0. 1, 2, 3. I'm at negative 2, negative 3. And 1, 2, 3. I'm at negative 4, 1. I took my function and I shifted down 3. For 17, I'm going to reflect. It's on the outside, so it's a vertical reflection, which means we're changing the y's. Okay? Now, when I say outside, I mean outside of the parentheses. So I'm going to go up here, and originally, this point was at negative 4, positive 4. So I'm going to write my original, negative 4, positive 4. The next point was at negative 2, 0. The next point was at 0, 3. The next point was at 2, 0. And the last point was at 4, 4. So I already gave my rule, which is a vertical reflection, so I'm changing all the y values. So my new point is going to be at negative 4, negative 4. This point, negative 2, you can't change the sign of a 0, so it just stays at 0. Instead of 0, 3, it's going to be 0, negative 3. 2, 0, you can't change the sign of a 0, so it's 2, 0. Instead of 4, 4, it's going to be 4, negative 4. I flipped it upside down to make an M rather than a W. On this last one, this is a vertical because it's on the outside of the parentheses, and it's going to be a stretch. So I'm multiplying all of my y values times 2. So if I go over here and I multiply all of these y values from my original times 2, my new point is going to be at negative 4, 8. Negative 2, 0 times 2 is 0. 0, 3 times 2 is 6. 2, 0 times 0 is 0. Sorry, 0 times 2. And 4, 4 times 2 is 8. I took my W and I stretched it out vertically. Sometimes it's easier to use the points than it is to use the picture. Last page, finding terms of an arithmetic sequence with a common difference. 3, 7, 11, 15. What's the common difference? We need to see how we get from one point to the next point. To get from 3 to 7, I add 4. 7 to 11, I add 4. 11 to 15, I add 4. So the common difference is 4. T5 means they want the fifth term. This is the first, second, third, 4th. So for the next term, I can just continue my pattern and add 4. So my next term would be 19. Write the explicit function. The formula is t sub n equals t1 plus d times n minus 1. All you plug in is the t1 and the d. So we would have tn equals, my first term is 3, plus my d is 4, parentheses n minus 1. And I could use any n value that I wanted to solve for that term. 20. An arithmetic sequence is described by this rule. What is T20? This right here is our T sub n. They're telling us that n equals 20. So I'm going to use this formula. T20 equals 1.2 times 20 plus 2. 1.2 times 20 is 24 plus 2. So T20 is equal to 26. Simple as that. This next part wants us to use recursive formula. Write the first 4 terms of the sequence described by the given formula. T1 is 12, so we're starting at 12. This is recursive formula, so this is our D. So each time I'm adding 7. So the next one would be 19, plus 7 would be 26, plus 7 would be 33. And that's the first 4 terms. Here, T2, T3, and T4 of the arithmetic sequence are shown below. Determine T1. So I need to figure out how we're getting from this point to this point. We could take 5.2 minus 4.5. Guys, this comes from our slope formula, y2 minus y1 over x2 minus x1. But the change in our x's are always equal to 1 for sequences. So 5.2 minus 4.5 is equal to 0.7. So for each time, I'm adding plus 0.7. So to go backwards to find T1, I'm going to subtract 0.7 from 4.5. That gives me 3.8. You could always check it. 3.8 plus 0.7, that equals 4.5. Alright, finding terms of arithmetic sequences with an explicit formula. Write the first 4 terms of the sequence described by the given function. So the first 4 terms. Guys, this is an equation you could plug in your calculator. N is the same thing as x. So I'm going to go to y equals and type in 85 minus 2 parentheses x minus 1. If I go to my table, I can find whatever terms I want to look for. But make sure we're looking for the first term. So when x is 1. So the first term is 85, which we could tell from our formula. And how much should it be changing each time? What does this minus 2 tell us? The D is we're going down 2 each time. So T2 is 83, T3 is 81, T4 is 79. And there's the first 4 terms. For 24, find term 38 for the arithmetic sequence with T1 equals -4 and T2 equals 4. Well, we have the T1, so we also need to find the common difference. So how do I get from -4 to +4? You're adding 8. So my equation for Tn, my first term is -4 plus 8 times n minus 1. Because my formula is T sub n equals T1 plus D times n minus 1. I just plugged in my T1 and plugged in my D. Now that I have my formula, I'm going to plug in my n value. What n value are they asking us for? 38. So T of 38 is equal to -4 plus 8, parentheses 38 minus 1. So T38 equals -4 plus 8 times 37. 37 times 8. So T of 38 equals -4 plus 296. So T of 38 is equal to 292. And that's your answer. This last part is talking about linear functions. Determine if each sequence is also a linear function. Circle yes or no. To make it linear, it has a constant rate of change. So we need to see if we're adding and subtracting the same thing each time. So you can take your y2 minus your y1. 5.5 minus a -1.5. So that's plus 7. 24.5 minus 5.5. That's plus 19. You can see from here that it's not linear. It doesn't have a D, or a common difference. So let's try this one. 4.5 minus 3. That's plus 1.5. 6 minus 4.5 is plus 1.5. 7.5 minus 6 is plus 1.5. So this is linear because it has a common difference. Here, the sequence below follows a pattern. What's the 10th term of the sequence? So we could use our explicit formula, Tn equals T1 plus D times n minus 1. So to find the 10th term, we're going to take the first term, which is 17. How do I get from 17 to 7? I'm subtracting 10. So my D is minus 10. Parentheses, the n value that they're asking for is 10 minus 1. So T10 equals 17 minus 10 times 9. So to get more room, I'm going to come over here. T10 equals 17 minus 90. So T10 equals negative 73. And that's the end of the review sheet. Please make sure you study for your exam on Friday.